everyone, how are you? You are fine. So in this video we will discuss about matter. Okay, so let's start. First of all, let's see what is matter. Okay, what is matter? Anything that having mass and also the ability to take space, known as matter. Okay, so here what is matter? Anything that having mass and also the ability to take space, known as matter. Okay, this pen is a matter. Okay, why? Because it have some mass and it also have the ability to take space. Okay, this one is our matter. This pen is a matter. Okay, on the now here on the basis of physical state, matter are divided into generally three states. Okay, first one is solid, liquid, gas. Okay, and there are two special state. That first one is that plasma state and second one is Bose-Einstein condensate. Okay, so this one is our the two special state of the matter. Okay. Now here is a comparison among solid, liquid and gas. Okay. Let's see the comparison between the solid, liquid and gas. Here is written general properties. Okay. First one is that shape. The shape of solid is fixed. Okay. Like suppose that this one is solid. Okay. So it have fixed shape. Okay. But liquid have not definite shape. Okay. If we put liquid in different container, it take that shape. Okay, that's why it has not definite. And gas also gas shape is also not definite. Okay, since not fixed. And second one is volume. Okay. The volume of solid is fixed. Okay, like this pen have the fixed volume. Okay, it cannot be decreased or increased. Okay, so the volume of solid is fixed. Okay, and the liquid volume is also fixed. Uh, but the volume of gas is not definite, not fixed. Okay, it volume would be decreased and increased. Now, our third general property is the number of particle per unit volume. Okay. So, in a solid, the number of particles per unit volume is maximum. Okay. And in liquid, it is intermediate, and in gas, it is minimum. Okay. And fourth one is that intermolecular distance. Intermolecular distance, or you can say intermolecular space. Okay. So in a solid, the intermolecular distance is minimum. Okay. That's why it is hard. Okay. That's why the solid are generally hard. And liquid is in liquid the intermolecular distance is intermediate. Okay. And in solid and in solid and in gas the intermolecular distance is maximum. Okay, and the fifth one is intermolecular force of attraction. Okay, in solid the intermolecular force of attraction is maximum. Okay, and in liquid the intermolecular force of attraction is intermediate, and in a liquid and in a gas the intermolecular force of attraction is minimum. Okay. And our sixth property is that molecular motion of particle. The solid molecular motion of the particle is almost negligible. Okay. And the liquid have intermediate and gas molecular motion of particles is maximum. Okay. And seventh one is that physical properties. Okay. So solid have I can say hard, rigid. Okay. Hard, rigid, non-compressible. Okay. Non-elastic. Okay. So these are the physical properties of solid. Okay. And liquid is physical property of liquid is intermediate. And the gas is loosely packed. Okay. Loosely packed, or you can say easily compressed. Okay. So these are some physical properties of this state, solid, liquid, gas. And last one is our density. Okay. In a solid, the density of solid is maximum, and the density of liquid is intermediate, and the density of gas is minimum. Okay. So there are some comparison among these three states: solid, liquid, gas. Okay. So I hope you understand this thing. Now move further. There is a point that all three states of matter can be interchanged whenever appropriate physical force is applied. Okay. Uh, all three state like solid, liquid, gas, all three state of matter can be interchanged when appropriate physical force is applied. Okay, that is solid. When we heat solid, it changes into liquid. Okay. And when we heat the liquid, it turns into gas. Okay, in the form of gas. And when gas is cooled, then it turns into liquid. And when liquid is cooled, then it turns into solid form. Okay, takes its original shape. Okay. When solid is when we heat solid, it turns into liquid, and when we heat liquid, it turns into gas, and when gas is cooled, then it turns into liquid, and when we cool liquid, it turns into solid. Okay. For example, take an example. Like ice is in a solid state, and when we heat ice, it turns into water. Okay. And when we heat water, it turns into vapor. Okay. When ice is heated, then it turns into water, and when water is heated, it turns into vapor. And again, when a vapor is cooled, it turns into what? Water. Sorry. And when the water is cooled with the help of refrigerators, okay, it turns into ice. Okay. So all three states of matter can be interchanged whenever appropriate physical force is applied. Okay. I hope you understand all this thing. That what is matter. Okay. Anything anything that having a mass and ability to take space known as matter. Okay. And matter is classified on the basis of physical state into three general states, that is solid, liquid and gas. Okay. And there is two special state, name is plasma state and Bose-Einstein condensed state. Okay. After that, we see a comparison among these three states, solid, liquid and gas. Okay. And after that, we see a point that all three states of matter can be interchanged whenever appropriate physical force is applied. Okay. Like solid is changed into liquid, liquid is changed into gas, and when we cool gas, it turns into liquid, and when we cool liquid, it turns into solid form. Okay. Now let's see about the special states. It is plasma. Okay. It is the fourth state of matter which exists at the highest temperature. Okay. Plasma is our fourth state of the matter. Okay, which exists at the highest temperature, that is 10 to the power 6 Kelvin. Okay. And there is one more point that plasma state is a gaseous ionic phase of matter. Okay. And this state is a gaseous ionic phase of the matter. Okay. For example, substance lying in the core of the sun and stars. Okay, these are in plasma state. Okay. Now let's see about Bose-Einstein condensate. This one is also this one is our second special state of the matter. Okay. It is a special state of matter which exists at absolute zero temperature. Okay. So Bose-Einstein condensate it is a special state of the matter. Okay, which exists at the absolute zero temperature. Okay, that is 0 Kelvin, or you can say minus 273.50 Kelvin. Sorry, not Kelvin, degree C. Okay, 273.50 degree C. Okay. So I hope you understand about all the thing that what is matter. Okay, that everything that having a mass and ability to take space is known as matter. Okay. And on the basis of a physical state, matter is divided into three states, like solid, liquid and gas. Okay. And special state of matter, plasma state and Bose-Einstein condensate. Okay. After that, we discuss comparison between among the three states. solid, liquid and gas. After that, we see a point that all three states of matter can be interchanged whenever appropriate to physical forces applied. Okay. After that, we discuss the special state like plasma state. Okay. It is the fourth state of matter which exists at the highest temperature. Plasma state exists at the highest temperature and it is the fourth state of the matter. Okay. Highest temperature that is 10 to the power 6 Kelvin. Okay. And plasma state is a gaseous ionic phase of the matter. Okay. And plasma state is a gaseous ionic phase of the matter. After that, we discussed about the Bose-Einstein condensate. Okay. Condensate. It is a special state of the matter which exists at absolute zero temperature. Okay. That is 0 Kelvin or minus 273.50 degrees C. Okay. Now let's see about the Dalton's atomic theory. Okay. According to this theory, according to Dalton's atomic theory, all matter is made up of a smallest particle known as atom. Okay. According to Dalton's atomic theory, all matter is made up of a smallest particle that is known as atom. Okay. The word atom is derived from a Latin word. Okay. That is atmos. Okay. It means atmos. Okay. From the word atom is derived from a Latin word that is atmos. It means indivisible. Okay. So according to Dalton's atomic theory, all matter is made up of the smallest particle that is what? Atom. Okay. Since atoms are too much small, they cannot be broken into broken. Okay. Atoms are very small. That's why they cannot be broken. Okay. That is atoms neither be created nor be destroyed. Okay. So our second point is that atoms are too much small. They cannot be broken. Okay. That is atom cannot be created nor be destroyed. This one is our second point. And the third point is that same elements contain same kinds of atoms, but different elements contain different kinds of atoms. Okay. Our third point is that same element contains same type of atom. Okay, and same kinds of atom you can say, but different elements contain different kinds of atom. Okay, this is our third point. Fourth point is that an element is made up of only one kind of atom, and these atoms are completely identical to each other in all respect. Okay, that is in shape, size, or even in mass. Okay, It means all elements is made up of the same same kind of the atom. Okay, and these atoms are completely identical to each other in their in the all respect. Okay, that is they are identical to each other on in shape, size, or even in mass also. Okay. The fifth point is that all atoms or atoms or elements when combined together in their fixed ratio, as a result, compound is produced. Okay. When the atoms or elements combine together, then it in their fixed ratio, as a result, they produce a compound. Okay. The last point is that this theory provides the foundation of laws of conservation of mass and laws of conservation of atom. Okay, and this Dalton's atomic theory also provides the foundation of the laws of conservation of mass and the laws of conservation of atom. Okay, so I hope you understand this Dalton atomic theory, that according to this theory, all matters is made up of the smallest particle known as atom. Okay. And since atoms are too much small, they cannot be broken. Okay. That is, atoms neither be created nor be destroyed. Okay. And our third point is that same elements contain the same kinds of atom, and the different elements contain the different kinds of atom. Fourth one, that an element is made up of only one kind of atom, and these atoms are completely identical to each other. Okay, that is in shape, size, or even in their masses. Okay. Fifth one is that atoms or elements when combined together, when atoms or elements combine together in their fixed ratio, as a result they produce compound. Okay. And the last one is that this theory, this Dalton's atomic theory provides the foundation of laws of conservation of mass and the laws of conservation of the atom. Okay. So this one is all about the Dalton's atomic theory. Now let's see the drawbacks of Dalton's atomic theory. Okay. So this one is the drawback of the Dalton atomic theory, that after the discovery of subatomic particles, like electron, proton, and neutron, it becomes clear that atoms is not a smallest one. Hence, it may be divided into subatomic particles. Okay. So this one is the drawbacks of Dalton's atomic theory, that after the discovery of the subatomic particles like electron, proton, neutron, it is clear that atoms is not the smallest particle. Okay. It may be divided into subatomic particles like electron, proton, and neutrons. Okay, so this is all about the drawback of Dalton's atomic theory. Okay, so I hope you understand about Dalton's atomic theory and drawback of Dalton's atomic theory, and all the types of about the matter and about the types of the matter. Okay, so I hope you understand whole the video. That's all for today. Thank you. Have a nice day.